Hello, everyone. This video is about Rate's law, or also known as rate expression, and how to find the order of reaction for both reactants or whatever reactants we have. So let's say a reaction like this is given to us. So for writing the Rate's law or rate expression, what we do is we always say rate equals to K, which is the rate constant, times concentration of reactant number one to the power of, let's say, N, and concentration of second reactant to the power of M. So in this case, N would be the order of reaction with respect to A, M would be the order of reaction with respect to B, and then when you add up the N and M, the sum of it always is equal to the overall order of reaction. So the way I wrote this is considered as the Rate's law or the rate expression for any reactant. So we have to investigate, we have to figure out what N and M are. We cannot just simply put some numbers, so we have to actually look into that. So there are three methods for finding the Rate's law and finding the order of reaction for the reactants. The first method is the initial rate method, which I already made a video about, so I'm going to tag it over here if you want to learn more about that. The second method is the integrated rate law method, so you have to look at some graphs in order to figure out what the order of reaction is for both reactants. And then the third method is called the reaction mechanism, so you have to look at the rate determining step to figure out what the order of reaction is. But let's say they've given us the order of reaction in some reaction. So let's say this is an example, and they told us, for example, the rate law is equal to K times A to the power of 1, B to the power of 2. So here I want to show you how changing the concentration of A and B can affect our rate of reaction. So let's say we are doubling the concentration of A, and we want to see how would that affect the rate of reaction. So since A is to the power of 1, once you double its concentration, you have to take 2 to the power of 1 as well. So we can see that because of that, the rate of the reaction is going to be doubled as well. But let's say we do the same thing for the second one, for B. Now we're doubling B. But since B is to the power of 2, you have to take that 2 to the power of 2 as well. So what it does is that it will make the rate to be 4 times more. So basically what we can say is B is way more effective than A because it's to the power of 2, so it has an order of 2. So basically when you double B, it's more effective than when you double A. So in this case, we can say the reaction is first order with respect to A, it is second order with respect to B, and then the overall order of the reaction would be 1 plus 2, which is 3 or third order reaction. Now let's take a look at another example. Same example, let's say the rate law is given to us to be this time K times A to the power of 1, B to the power of 3. So same idea. Now I'm going to double A and see how would that affect my rate. And because A is to the power of 1, 2 goes to the power of 1. So therefore the rate will also be doubled. By doubling B, because B is to the power of 3, the 2 has to go to the power of 3. So this time the rate will be 8 times more. So again, definitely B is way more effective in the rate of reaction than A. So both of the reactants are affecting our rate. However, B is actually having more effect on the rate of reaction than A. So reaction is first order with respect to A, it's third order with respect to B, and then the overall order of reaction is fourth order, the sum of 1 and 3, which is 4. Last example, let's say this time they gave the rate law to be K times A to the 1, B to the 2. So this time, instead of me doubling the rate, I want to try tripling the rate, the concentration, sorry. So I'm timesing the concentration of A by 3, and I want to see how would that affect the rate of reaction. So since A is to the power of 1, 3 goes to the power of 1. So by tripling the concentration of A, the rate is also tripled. However, if I do the same thing for B, if I triple the concentration of B, since B is to the power of 2, 3 has to go to the power of 2, so rate will be 9 times more. So same idea, we can see that how each reactant is affecting our rate, and reaction is first order with respect to A, it's second order with respect to B, and the overall order of reaction is third order. Okay, so that was it for this video. I hope you enjoyed it. If you did, please make sure you like it and subscribe for watching more videos. And if you have any questions, make sure to leave it in the comment section. Hope to see you in the next video.